Hi, this is Group 6, and in this video we will demonstrate our robot in one of our test runs and from the second run of our competition. As explained in the report, we use image analysis methods to identify objects. We use this to identify the balls, the robot, the border, the egg, and the cross. What you see here is our monitoring view where we can see what the robot is seeing. In the top left corner, we have the navigation through the save points. The yellow save points are the inner ones, and the green ones are used for special cases. Bottom left corner is just our monitoring, where we can see what state is the robot in. Is it going for the cross? Is it going to deliver? Stuff like that, or pathing. Top right corner, we have identification of our balls. Right here, it's the easy balls as we prioritize, and bottom right is just the identification of the robot. To plan a route, we use a very basic breadth first search. We find the entry point to the route by finding the nearest point to the robot, and the exit point by finding the nearest point to the ball or deposit point. Most balls only use the standard yellow save points, but if the ball is near the corner, then the nearest of the additional green endpoints is used as the endpoint of the breadth first search before going for the ball. This allows us to get a better angle to collect the balls in the corner, as we had some problems picking those up. To collect the balls near the cross, we have to be very careful. Our method consists of a few steps, and it's a different or specific state called cross state. And we use a lineup. We have sneak forward, then we have turn on belt, turn off belt, and then reverse. The lineup step is by far the hardest of these. First, we draw a vector from the center of the cross to the ball near the cross. This vector is then normalized to length 1 and multiplied by a factor, so we have plenty of space. This is then the point used to as exit for the breadth first search. This allows us to always line up from the most open side of the cross, no matter the orientation. We then move very slowly and back up once we have attempted a pickup. We have also prioritization of routes. So what we do is we go for the normal balls first, then we go for the center ball, which you will see in a second, and then we go for the orange ball in the end. Um, we go for the center balls before the orange, but after all the other ones, because the center ball is risky, as we risk pushing the cross, which happened to us in the competition, and not being able to collect balls because we locked them into a corner, for instance, which also happened in the competition. We do, however, have to collect the orange ball last to deliver it first to get extra points. We have tried to do a lot of fail safes in our system, um, but one that we did clearly not handle very appropriately is the case of eating the cross. We tried to handle this by always reversing out of the center when we were finished picking up balls in the center, which generally worked well, but since the cross in the competition was accidentally pushed into the save points, we ended up eating it later when we navigated through a save point that now had a cross in it. So what we should have done was put save points all over the place and then identify if a save point is close to the cross, then it could not use that as navigation. Um, the failsafe we did was we used timeouts. So if we're going for a ball but it did not happen, or we're going for an objective and it failed, then we would time out the system and try again. Go back to a save point and try again. You will see that in a second when we are eating the grass. We have reversing, so we can go back from edges. We have pathing around sensors using this save points. We have very low tolerances on delivering, which means we always make sure that we actually deliver in the small goal. We quit delivery if a ball is detected, so sometimes we can shadow a ball and then we go for delivery, but then we will see the ball and we will go back and pick that up and then go delivering. We're not detecting moving balls, as those cause a big problem. Um, if you try and go for a moving ball, you have very hard time picking it up. And we're locking onto balls to stop shadows blocking. So even if we block a ball with our robot, we will still go and pick it up, and then we reset the timer when we're sure we picked it up. And we're not detecting balls outside the map, so it doesn't get confused when delivering and going into a different state. And what you can see here is actually a timeout happening, where it goes back to a save point, and then it will try from a different angle to pick up the orange ball, which failed, unfortunately.